So this is a kind of lesson that we'll look at bringing everything that we've learnt so far together and start to understand the process of what happens when you connect to a website. So we use the internet on a daily basis, but do we realise what is involved in this? Probably not. Probably don't realise how much is going on behind the scenes in the split second that it takes for you to access a website. But actually there's quite a lot that's going on. So what's operating in the background for us to do this? Well, we're going to have a little look and see exactly how this works. So we're going to understand that the internet is a worldwide collection of computers, the role of DNS, which is a very important thing to understand as part of the internet, understand what is meant by hosting, what is meant by the cloud, what is meant by a virtual network, and why virtual networks are used. Okay, we're going to skip through that just for now. So there are some keywords there: internet, DNS, hosting, the cloud, virtual network, and VPN, but we'll circle back to them at the end. So the internet is a worldwide collection of computer networks that are connected together, or interconnected networks. They operate on protocols such as TCP over IP, and protocol really at its simplest form just means a set of rules. So a protocol might be what you do in a fire drill, or how you sign in if you're late for whatever reason, whether you're going to an office or to school, how you make people aware that you are coming in and you're on site and you're present. When we are having computers communicate with each other, it's important that they're both using the same rules so that they can understand each other. And so they have protocols for how they communicate, and one such protocol is TCP over IP. Now, DNS servers. So when you're accessing a web page, we use the URL to access the page. So we've got an example there, http://www.ocr.org.uk. So let's have a little look here. Let's just do a little, let me just write that out. So http, I think it's : / and then we've got www. What was it? ocr.org.uk. ocr.org.uk. I do apologise, my handwriting on a computer should get better shortly. So this here, it's almost like I'm drawing it by hand. This here is the protocol that is being used to send this information. Okay, so we have selected a hypertext transfer protocol, and that's what HTTP stands for. Let me just hypertext transfer protocol, HTTP, and that is essentially just saying how hypertext should be transferred, the rules for how that should look, how that should be transmitted. And so we are using hypertext transfer protocol to access this website. Now we have the www, which stands for World Wide Web, so it's a resource on the World Wide Web. We have the kind of host name, if you like. So if we go back here, HTTP tells a computer to use hypertext transfer protocol, which puts packets together to be used in a web browser. www tells us that this is a web page and that it is located on the World Wide Web, and ocr.org.uk is the domain name. So this bit here is the domain name. And if we wanted to get really specific, this .uk would be the top level domain. Ooh. Oh dear, that's not very good, is it? Let's try that again. Domain, and this would be the second level domain, the org. Okay, and the www is a web page. Okay, now this is very, I don't know, theoretical. You could go somewhere that doesn't start with www and still get a web page, so it's kind of outdated now, I'd say, but that is kind of the general gist of what's going on with www. So that's our URL. Now, this whole thing is what's known as a URL. I really annoys me when people call it L, a URL. You can call it L. I'm happy for you to do that, but I just know that I will be annoyed. Now, secretly, I'm going to call this a uniform resource locator, and we're going to call it that because that's its name. Okay, I really apologise for the state of my handwriting here. I am bad enough writing on a whiteboard, let alone a digital whiteboard. So this is our URL. Let's draw a little box around that. Oh my lord. Okay, so this is our uniform resource locator, and that's pretty much how it breaks down. Now, why are we talking about this? Well, we need to know about this to know about what a DNS server does. So a DNS server takes that URL, and if we go back to our diagram here, let's, can I do this? Yeah, great. So let's go across here a little bit. And let's start setting ourselves up to understand this properly. So what colour have I got? I should have white. So let's set ourselves up a little LAN. So the first thing we need for a LAN is an incoming connection. I'm going to draw a little, let's draw a little LAN bubble. No, let's draw the LAN components first. So an incoming connection, let's have something like this little box in my wall. Okay, so if I draw this in a different color, that's going out into the internet. And now my incoming connection, the first thing it's going to come into is a router. Now your router might have a WAP built into it, or it might not, and it might have a switch built into it as well, or it might not. So let's give those all a label. So we've got ourselves a router, got ourselves a WAP, which is a wireless access point, and we've got ourselves a switch. And they could all be in one device, they could be in 3 separate devices, but it's just important that you understand what each of those does. Now, my WAP, I'm going to give some little antenna, I think, to show that it is connecting to things wirelessly. Cool. And you can see here the router is having the outside connection, this connection to the internet. And inside here is our little network. So I might have let's come down here, might have a phone. That is connected to my WAP by Wi-Fi. And I might have a laptop. And that might also be connected to my WAP by Wi-Fi. I might have a desktop computer, much like you would have at school. And that might be plugged into my switch. I could have a printer pop a little thing out there, that's good enough for a printer, and that might also go into my switch. And you can see here that we're starting to build up our own little home LAN. So local area network, and this is our LAN. Okay, the first thing that comes in from the internet is into our router, and our router dishes everything out. Now, our router is in charge of assigning everything an IP address. So I could, let's do some typical IP addresses. So my computer here might be 192.168.0. Let's say 2. My laptop could be 192.168.0.3. My phone could be 192.168.0.4. What have I got over here? I've got a printer, so that could be 192.168.0.5, and then my router's IP address would be number 1 because it sets itself up before anything else. 192, and 192.168 is a very common, or it's actually a reserved IP address for your LAN. Now 192.168.0.1, and if you go home, or if you're at home and you type that into your browser, you will probably be greeted with a page from your router. It might be like Virgin Media or something, or whoever your service is with, and it will probably be to log into your router there. Now, these are what are known as private IP addresses. Let's do that in this. So, private IP addresses. So that's a private IP address. That's a private IP address, and everything that the router has dished out to us is what's known as a private IP address. Now, because it's private, no one on the internet, no one over here on the internet can see those addresses. Only the router knows what those addresses are. Now, as well as having a private IP address, the router will also have a public IP address. So it will have a second IP address that might be something like, I don't know, 86.15.102.56, and that is the router's public IP address. Now, a public IP address is something that people can see on the internet, and you could type in, you could find out the public IP address for, I don't know, Google's website, and you could type in their IP address and it would take you to their network. And if they had set it up correctly, which I'm sure Google have, that would allow you to access their webpage. Now, if I just come over here a little bit, let's imagine that we have another network connected to the internet. What color am I on? So let's imagine our line comes over here, and there's a big exchange where lots of lines meet, and I have another network that's connected to the internet, and that goes into a box on their wall in their house somewhere, and then that goes out to their router, and their router has a built-in WAP and a built-in switch, and so they have a phone down here. My drawings of phones are disgraceful, and I do apologise. Laptop. Do you know what? This drawing tablet is not agreeing with me. We're not getting on. More practice needed. What else did I have? I had a computer. and that can be connected in by Ethernet, and I also had a printer which can be connected in by Ethernet as well. So we've got our two wireless devices connected to the WAP functionality of our router. We've also got a computer and a printer hardwired in by Ethernet into our router, and then we have our outgoing internet connection going off from our router. Now our router in this LAN here, this is a separate LAN, so I'll just this is a LAN. Our router will have a private IP address that will be exactly the same as the other one, 192.168.0.1. And our phone could potentially have exactly the same. I'm just going to say this is 192.168.0.2, and then our laptop 192.168.0.3, almost there, 192.168.0.4 for our computer, and then finally our printer 192.168.0.5. And so all of our kind of devices inside have the same numbers that other LAN devices on another LAN have. So if we were to zoom out a little bit, okay, you can see here that this LAN has a router with 192.168.0.1, and so does this router over here in this LAN. And that's okay, because we do this all the time. If you've ever been to a hotel, you might have had a room that's had the number, your room number might have been 101, and just because another hotel has a room with that in doesn't mean that you instantly get confused and end up in the wrong room. The idea is that you can kind of, maybe the hotel analogy we might put to rest for just a second, but you can essentially identify a network with its public IP address. So this here, it has a public IP address, and then once you have got into that network, the router will then know which device you should be talking to and be able to send you on. And so this allows us to have lots of devices connected to a single point that has a single IP address. And so all the devices on your network will have a local IP address, and your router, when it's connected to the internet, it will have its own public IP address that people can look at, and this router would have a different public IP address. The public IP addresses have to be unique. So this could be like 94.200.1.1. Okay, and that's another public IP address for this router. Everything inside has a private IP address, just like we do over here. And so these can be kind of duplicated. Now, why do we need to know about this? Well, on the internet, there are these things, and if we're connected to the internet, we can access them, called a DNS server. DNS, and it is a server. So server being something that can fulfill requests, and you can ask for something and it will return you something. So we can have a DNS server. So what is DNS? DNS is the domain name system. And we just looked at an example of a domain over here. Okay, and so there is a system for how domain names should be set up, with top level domains, second level domains, having this kind of start thing, www, and having the actual kind of middle host name, if you like, at the middle there, and the protocol that it's using. These are all, well, the protocol is actually separate to the domain name, and so is I think the subdomain is slightly different, but this here, there is a system for it. And if we go to here, so the DNS has a list of all domain names and their associated IP addresses. All packets are transmitted as IP addresses, therefore to access the server that holds the OCR website, we would need to know the IP address. So when I go to this kind of laptop here on this network, and I want to access ocr.org.uk, okay, when I type that into my browser, ocr.org.uk, it doesn't just go through here into the internet and off into OCR's kind of, let's imagine that this is OCR's network. It doesn't just go into there and find it. It actually has to know what ocr.org, what IP address that relates to, what public IP address. So let's imagine, let's shift the paradigm here a little bit. Let's imagine that this is OCR's LAN, where they are hosting their website. And let's imagine this is us over here in a completely different area, completely different, maybe different county or country even, and this is our kind of network over here, and this is OCR's network. Now, when we type in ocr.org.uk, the request first goes to a DNS server, and a DNS server has a list of all of the different websites that are registered. And as a quick example, if I can, let's just jump in and go to GoDaddy. Cool, so GoDaddy is a registrar, and so you can register your own domain there. So I could say something like Mr. Johnson Computing, and I can see that mrjohnsonComputing.co.uk is taken because I own that. I've already bought that, so you can't actually take that because it is registered, and there's only one of it. You're not allowed to. If I went to another site, let's go to another 123reg, and let's try and register it with them. Accept. Search for my perfect domain, Mr. Johnson Computing. mrjohnsonComputing.co.uk has already been registered. So you can register a domain once with any registrar, and that will be registered across the board. Okay. Now it does look like mrjohnsonComputing.com is on sale. Look at that, £5. So we can see all the different ones that are available through this registrar or through anyone. Okay, and GoDaddy will have a similar idea. mjohnsonComputing.co.uk is a penny. Look at that. JohnsonComputing.co.uk is a penny. Well, I need to get on this. Okay, Mr. Johnson-Computing. There's loads. Okay, so there's loads and loads and loads of different domains that aren't registered that I could buy. Now, when you are buying a domain through a registrar, you are just renting it. You are paying. You can see here for the first year with a 2-year registration. So I would pay 1 penny for the first year, and the second year it looks like I'd pay £11.99, so I'd pay £12 in order to have this domain for 2 years, and then after that 2 years I'd either have to renew my contract with them, or I would it would just expire and go back for anyone to take. And so this is the idea of domain names. They are sold by registrars, and there is one big list of them kept, and that is kind of copied across loads of different places so that everyone is kind of on the same page, if you like. And so we have our DNS server here. And when you go to OCR, what you're actually doing is you're sending across ocr.org.uk. And the DNS name system, the DNS server, will have a big table with all of the different domains and their associated IP addresses. So it will have, this is obviously a very simplified version, but it will look up what I've sent, so ocr.org.uk, and it will have next to it the IP address, the public IP address for that service, 102.56. And so my request will first get beamed. Let's go through in a different color. Let's choose red. So my request will first get beamed through here into my router. My router has a routing table in it, and it will know where the kind of nearest DNS server is. So it will send my data off into the internet, and that will go through into the DNS server. and the DNS server will take that ocr.org.uk that I've typed into my web browser, and it will look it up in its big table full of domains. Now, I've just drawn one because I am thoroughly lazy, but it will have a look at all the different domains it has, find a match for ocr.org.uk, and then it will return this IP address to my computer. So that IP address will be sent back through the internet, back to my router, and back to my laptop here. Okay. Now that I've got the IP address, my computer can then send that. I can kind of send data straight to that IP address. So then, now that I've looked up through the DNS server, the domain, got the IP address. The IP address has come all the way back through the internet, back through my router, back to my laptop. I'm then going to go back out with that IP address that they've just sent me, okay, into my router again, and my router this time will go off, and instead of going to a DNS server, because I've just got the IP address, I'm going to go straight through the internet to that public IP address here, and I'm going to come into this router, and then this router will say, yes, I know there's a web server on here. Oh dear. I know there's a web server on here, and I will be able to send you back that resource. So then finally, it will forward my request on to the correct computer. So my request gets kind of forwarded through to the switch sends it off to this computer, and it says, hey, I know that you're running a web server, this person has just requested a page, and it will say, yep, I know how to do that. So it will send a hypertext transfer protocol response back through to the switch back through to the router says, I know, I have my routing table, I know where this is going to go, and it goes through into the internet with a certain amount of hops, and then we go back through the internet, back to our router, and our router says, yeah, I know who's waiting for a response from this, and it sends that back to your laptop, and your laptop has loaded a web page. Now it goes through all of that just to get a web page, okay? That is quite a journey, but it does it in kind of milliseconds, which is incredible, absolutely incredible, just black magic really. And that is how the DNS server works, okay? That's how DNS works in kind of networking and accessing websites. Clear as mud? So the DNS has a list of all domain names and their associated IP addresses. It'd be useless if the DNS didn't have all the domain names, we just had half of them, and you search for a website that it didn't have on the list, then you wouldn't be able to access it. So it has a list of all the domain names, and all the packets are transmitted as IP addresses. Therefore, to access the server that holds the OCR website, we would need to know the IP address. Now, it would be useless, absolutely useless for our human brains if we had to remember all of these different public IP addresses. And so we've made this nice human-friendly domain name system, okay? Domain name system, and we stick our domain name system server up and running, which has a big table of domains, a big table of their matching IP addresses, and then it's easy for us to match them up on our computers to kind of do all the hard work for us. So we just have to remember their nice friendly names rather than just a series of numbers. Now, just a quick bit of binary. So if we were to have a look at a 8-bit number, oh, I'm in red. Yeah, let's stick with red. So 1 0 1 1 0 1 1 0, and let's swap to white. Let's pop our column headings in for this binary number. I've just plucked this out of thin air. I don't know what this number is yet. Okay, apologies for my terrible all-round use of this graphics tablet. So we've got 1s, 2s, 4s, 8s, 16s, 32s, 64s, and 128s. Now, the way our binary numbers work is that we add these up. So if I was to add this number up, I would have 4 add 2, add 16, add 32, add 128. If I add the 2 to 128, I get 130. Add the 4 to the 16, I get 20. Added to that, it's 150, which makes 182. So that binary number would equal 182. I really hope that's right. If it's not right and you're screaming at the screen, then I do apologise. Now, if we had all of these as ones, or all of these as zeros, that would give us our maximum range for what numbers we could make in an 8-bit binary number. So these are 8-bit binary numbers that we've got here because they're made up of a sequence of 8 digits, binary digits, or bits as they're called. Okay, so if I have all zeros, let's do the easy one first. If I have all zeros, then obviously I have 0. I have 0, 1, 0, 2, 0, 4, 0, 8, blah, blah, blah. I have 0. Now, if I have all of them, let's add them all up. So 128, add, let's make this easy for myself. So 128 add 32 is 160, and then let's add the 64, so 224. Sorry, 228. What am I talking about? No, sorry, I did 64. 224, yeah, I'm right. So we've done 64 as well, and now let's do 16 and 4 will give us 20, so that's 244. And now we just have 8, 2 and 1, so 8 and 2 is 10, so that's 254, and then add the 1, 255. So here, all of the ones are 255. Now if we make an IP address that is a sequence of 4 8-bit numbers, then the range of those 8-bit numbers is going to be between 0 and 255. So every IP address, it's going to have something dot something dot something dot something, and these numbers in between the dots have to be between 0 and 255, because they are essentially just 8-bit binary numbers. But when they're written like this here, we're just putting them into denary, but they're always going to be in between 0 and 255, and at the fundamental level of what's going on in the computers is they are just binary numbers. So it might be 1001, 0011, 111, 011, 00, 0000, 1111, or 10000001. Okay, and so that could be our IP address, and obviously that's just in binary, but that's why your IP address would never be larger, any individual number would never be larger than 255, because we're using 8-bit binary numbers. Okay, so where are we? Without a DNS server, the user would have to type in IP addresses to access a web page, which would be very inconvenient for our human brains. So in order to let people see your website, it will be placed on a web server. This is known as hosting. You would select a suitable domain name, such as myinterestingnetworkingsite.co.uk, and you would need to register that domain name with a domain registrar. They would ensure that the domain name is unique and not already registered. So you can see that when I went onto the registrar, you could see that mrjohnsoncomputing.co.uk was registered, and so obviously we couldn't have another copy of that. You can only have one google.co.uk, you can only have one youtube.com, you can only have one mrjohnson.co.uk. Each registered domain name would have an associated IP address. This would then be registered on a DNS. So when I register my mrjohnsonscomputing.co.uk, I run it off my own server from my own house. So I have to find out my own public IP address, It's not this, but this kind of, I think it might begin with 86, I don't know. Check your IP. I think Folkestone IP addresses start with something in the 80s. And then yeah, I give that to the registrar, and it is then able to connect that to the DNS server and allow anyone typing in mrjohnson.co.uk to find my IP address and go to my LAN where my web server is operating. Okay. 5-minute challenge. Go to a registrar's website and try to make the most expensive domain that you can. So there, you've seen me go to a few registrars as well. You saw that there were some that are on there for a penny. You will find that there are some that are on there for a lot of money. So pause this video, jump onto registrar, have a little look around. Note 2 things: the price of them, but also the different domains. So here we've got .org.uk. What else can we have? .something else, kind of .gov.com. But what else is there? Have a little look at that, because there are some crazy last kind of top level domains there. So give this video a pause, go have a look, see if you can find something expensive, and we'll wrap this up once you're back. Cool, welcome back. The magic of video. So let's have a little think about the cloud. The cloud is a network of servers. Some servers will run applications, some servers will store data. The benefits of the cloud is that you can increase storage. So if you're kind of running out of storage on your mobile phone, then saving data to the cloud can be very beneficial because it's not stored on your phone. You can access files from anywhere in the world, and you can collaborate with others from around the world. Okay, I didn't mean to do that, let's go back one. So the cloud, how does this fit into our diagram here? Well, let's imagine that we've got another LAN. So, what colour am I in? Yep, cool. So I've got a kind of incoming socket here coming into my router that has a WAP built into it and a switch built into it, so everything can connect. And all I've got attached to this is for simplicity's sake, I'm just going to say one server, but you could have many servers. We're going to call that a server, and that's plugged into my router. Let's just go back to this color. Cool. So we have ourselves a server, we have a router, and we have our connection to the internet. Now this, obviously, everything doesn't just connect to one central point, but I'm just going to doing this in this diagram for kind of just this box up here. Just think of it as the internet, and a very abstracted version of it. Now this server here, we can connect to loads and loads and loads and loads and loads of secondary storage. So these could be hard disk drives, which are obviously magnetic. They could be SSDs, so solid state devices. They could be anything. So let's imagine that this is just full of little hard disk drives, this big rack of drives that are all plugged in and all spinning away. And we'd have loads and loads and loads of these. So these would all be secondary storage. And our server is able to take requests, retrieve data from that secondary storage, and send it off to you. So if I am, let's move over here. If I'm outside of my house and I have caught a train, okay, and I'm sat on my train seat, and I'm trying to view a file on my phone, and my phone is connecting to a kind of 4G mast that the train is passing. It's broadcasting its radio frequencies, and my phone can connect to that. And this mast is connected to the internet, so let's just plug this cable into this one. Let's pretend there's a little kind of, I don't know, box here that things can connect to as well. And this mast is connected, and it is broadcasting frequencies, and so my phone can connect to the internet by going through to this mast and through to this box. Now this is really powerful because if I want to access some of my storage, as long as I'm connected to the internet, I have a path where I can send a request to that server going through the tower. The tower can go to the DNS server. The DNS server can return to me the IP address of my kind of cloud supplier. That can come back to my phone. My phone can then go direct to the cloud provider, and it will fulfill my request. So this will come in and it will ask, can I have, you know, that file or that web page or something, and it'll send it back to my phone. Whoop. Back through the mast and back to my phone. Oh dear, that didn't go too well. Back through the mast, back to my phone. And this can happen regardless of where I am and what device I'm using. So as long as I can connect a device to the internet, I'll be able to sign in and I can access my storage that's on the cloud. And this always stays put, but as long as I'm connected to the internet, I could come home and I could sit down at my computer and I could do the same thing. I could make a DNS request and then I could pull out my my data from my secondary storage. And so if I have like a Google Photos account or something, I would be able to access all my photos from any device as long as I can sign into it and connect to the internet. And that's the idea of the cloud, that it's not stored here on my device and I can't access it when I'm on the train because it's stored here on my device. It's stored on the cloud over here. Let's give that its name. So this is the cloud, and because it's stored on the cloud, I can access that from anywhere. Now you could obviously set up your own little cloud at your house if you wanted to, that allowed you to access and kind of get files from it, but cloud companies obviously spend a lot of time and money in making sure that their services are secure and not easily hacked. And if you were operating your own kind of little remote accessible storage device, it might be vulnerable to attackers. So I would just be kind of wary of doing that if you were thinking of starting up your own. But you can see here that this is really powerful, because no matter where you are, even if you're on the train, if you're at school, if you're at home, if you're in an office, you'll be able to sign in, as long as you're connected to the internet, to this cloud provider and get your data. So you don't have to rely on it being on a single machine. If you lose that machine, if it breaks, then all of your data is over here. And also, it's not just here in one place, it's being constantly backed up around the world, so that if one facility was to go down, if this area was to go down, there would be another one that had a copy of your data. And so it's kept safe, which is really important. Okay. Let's go back here. So some servers will run applications, some servers will store data. So we could have the exact same idea over here, but instead of it providing you loads of storage, it will provide you data. Yeah, but sorry, it'll provide you an application that you could use. Sorry, my Photoshop just seems to have stopped working. Great. Okay. Don't know why, but we will move on. Okay, so obviously the benefits of this is that you can increase storage, so you can have a lot more storage than your physical device might have. You can access your files from anywhere in the world, and you can collaborate with others from around the world. So if my file exists here on this secondary storage, I can send someone a link for them to be able to access it and be able to collaborate as well. And that's where things like Google Docs, Google Sheets, and other cloud products allow you to really work collaboratively. Okay, so 2 videos. I'm going to post links to these on the assignment or in the video's description, or maybe both, to let you know, to kind of explain what a virtual private network is. I'd like you to watch them and then answer these questions. What is a virtual network in general? What can they be used for? And when you come back, actually no, not when you come back, I'd like you to construct a mind map to represent the abilities of a virtual network. So watch the videos, maybe do a little bit of research, and then I'd like you to make a mind map on the different things that a virtual network can allow you to do. So hopefully you paused it there and you watched those videos and completed that activity. So, virtual networks. Within a LAN, it's possible to break the network into virtual networks to allow one group of devices to not see each other or to not see another group of devices on the network. So, for instance, it might be helpful for you to separate some users from others so that they can't see each other, like administrators and school users. They share the same network hardware and cabling, but the software determines what you can access and what you can see. It's easy to maintain a network like this because you can just plug everything in. You don't have to worry about where it's plugged into, and then you can just manage it through software, and allows you to be quite flexible in how something is set up. And if you wanted to remove a computer or add a computer to a certain group, you don't have to rewire it yourself. You can just plug it into where it needs to be virtually. Machines can be added and removed from a virtual network without having to rewire. So that is a kind of why you might use a virtual network. Okay, let's ignore activity 2. Let's ignore the plenary. Okay, that has been a lot to go through. Okay, please make sure that you have read and researched about virtual networks. I've done a lot of talking, so I'm not going to talk through that section. I'd like you to do some independent research on that. And I would like you to make sure that throughout this, I should have said at the start really, but throughout this video you should hopefully have been taking notes. If you haven't been taking notes, now would be a great time to go back and do it, but hopefully you would have had the sense to go through and take notes as you were going through them. Now, the main kind of things are kind of taking notes of these. You can obviously do a much prettier job of making these look nicer, okay? And yeah, remember this is your education, these are your notes, so please do make sure that you are producing worthwhile resources for this. So this has been, I think, maybe the last section of wired and wireless networks, or maybe it's the first section of the other one, I don't know. But yeah, there's still a lot of networking to go. I think there's another unit's worth, but I think this is brings us to the end of our first one. Let's just double check. Where are we? Wired and wireless. Yeah, this is the last of our wired and wireless networks. So next lesson we will be looking at a bit more kind of in depth about how transmission over the internet actually works. Sweet.